Hello everybody, this is Solar Tiger with another wind power video. Today is Sunday the 11th of November. Okay, as I was telling you before, I was having very poor output from the wind turbine. The highest wattage I've ever seen was about 7 watts at approximately half an amp, and I'm generating approximately half an amp hour a day, all of which is not very good when you need to charge a 300 amp hour battery bank. So today I had the wind turbine down. You can't see very well now because it's about 5 o'clock in the evening, but the wind turbine is the white triangular dot in the middle of the screen. And I had it down and I had it apart and to see if I could see any way of improving the output. I looked at the magnets in the alternator and they're not very strong, so I think that's the cause of the problem. If I touched them with this screwdriver, the pull was very low. It didn't pull the screwdriver to them very hard. So I think the main problem I'm having is that the turbine has to spin a lot to produce any voltage, but as this is a AC wind turbine, the output voltage from the turbine is an AC voltage. I had a cunning idea for an experiment. The thing I need to charge my batteries is a higher voltage from the wind turbine. I'm not so fussed about the current, but to charge the batteries I need over 12, nearly 13 volts to actually start charging the batteries, and I noticed it took a lot of wind to produce 13 volts. So I had an idea to boost the output voltage from the turbine. Since it's an AC voltage, I thought I could put a transformer between the turbine and the input to the bridge rectifier in order to step up the voltage. So what I did was I went into my junk collection, my junk electrical parts collection that I have, and I took a mains transformer that came from an old printer power supply. It's the one that you used to power the printer from the mains. It's just a mains transformer. Transforms the voltage down to a lower voltage to power your printer. So what I did is I took the transformer and I connected the low voltage side of the transformer to the output from the wind turbine, and the high voltage side of the transformer I connected to the input of the bridge rectifier, and I ran some tests in the garden. So I connected it up and I connected a voltmeter across the output of the rectifier, and with the turbine laying down I turned it by hand, and with this new setup, when I turned it pretty slowly I was getting over 13-14 volts. If I turned it a little quicker I exceeded the voltage range on the meter, which was on the 20 volts DC scale. It went off the scale, so that was promising, and I was only turning it fairly slowly. So I connected the rectifier back to the cable that goes to the charge controller, and I turned it again by hand, and I was getting over 10 volts, and I was turning it quite slowly, so it looks promising. So what this does is the transformer will step up the voltage from the wind turbine, and then the stepped up voltage will be rectified with the bridge rectifier, and then it goes into the charge controller. The idea being that I can keep the voltage higher with the turbine turning slower, and it's the voltage I need to exceed the 13 volts to begin charging the battery. And that's the problem I was having before, that the wind turbine had to turn pretty fast in a stiff wind just to get to the battery voltage. So hopefully this idea will mean that I will charge the battery with lower wind speeds. The idea being that a smaller charge all the time is better than a higher charge very occasionally. So this is just an experiment. I put the transformer in the shed along with the rectifier, and now I'm just waiting for a windy day to see if this setup can produce any more power. Bearing in mind, before I hit a maximum of 7 watts, a current of approximately half an amp, and approximately half an amp hour a day, and I hit a maximum of 2.6 watt hours in one day before. Today was very sunny and I had a good day with the solar. We peaked at a wattage of 96.8 watts from the solar panels. That was a current of 2.78 amps. I generated 307.4 watt hours, which was 8.47 amp hours. So that's pretty good output. I haven't seen that for a while now. And I charged the electric bike battery, the metal detector battery, the power drill twice, the hedge trimmer battery, and I am using my 12 volt DC charger, and the batteries are at 12.62 volts, and I'm having a good day with the solar, and hopefully my experiment with the wind turbine and using a transformer will hopefully produce better results from the wind turbine. So I will see what happens when the wind blows, and I will update you accordingly. This is Solar Tiger saying thank you for watching, and until next time, goodbye. Thank you.